Welcome back. So far we have seen in the previous two lectures a lot of examples, some simple, some slightly difficult, some from previous exams, JEE exams, about how to determine range and domain of a function. What we will try to see today is some properties of some commonly occurring functions. So these functions are those that you will see not only in your math textbooks, but also in other applications in physics, chemistry, and sometimes in day-to-day activities. So one of the functions that appears a lot and that you would study more in math as well is the sine function. So this is a function that comes out of trigonometry. So for those of you that know, sine is defined for a right angle triangle by this relation. So if this angle is theta, and let's say this is y and this is x, and this is 90 degrees, so this will be x squared plus y squared. So in this case, sine of theta, which is denoted by sin, e is omitted, is given by y over square root of x squared plus y squared. Now sine function is fairly historic. It was used by a lot of in a lot of places across the world even 2000 years ago, and I don't know much history, but I know that the word sine is actually originated from Sanskrit, which then traveled across the world, got transformed into Arabic and then into Latin when it became sine. So if you're interested in history, definitely read more about it. So sine of theta is given by this equation, and as I said, it appears in a lot of application, and it also appears in a lot of functions on a lot of questions on functions that we'll see today, and also perhaps you'll see them in exams. So this is one way of defining sine that you might know. Another interesting way to see how sine is given is to look at a circle with unit radius. So let's say if we have a circle whose radius is equal to 1, then, and this is the angle theta for a vector, then its projection along the x-axis, so this is essentially cos of theta, which is something that we'll know, and this is sine of theta. So you can just think of a circle, take this vector and try to rotate this around to figure out what the value of sine is, or roughly what the value of sine is. So oftentimes you will see you need to know roughly what the value of sine is, and you can and you don't know what the value of sine is, so you can just remember this figure. So let's say if I take a vector which is like this, let me try to use a different color. So if I take a vector along this for which theta is negative, then sine of theta, which is along the y-axis, which is like this, is also negative, because this is the positive x-axis, this is the positive y-axis, this is 0, and the projection along the x-axis is still positive, and that is given as cosine. So this is a very important tool in case you have forgotten the values of different values of sine, and you just want to quickly remember. And there is a very good graphic of this in case you want to look at on Wikipedia, where you can see an animation where they rotate this this vector and you can see what happens to the values of sine and cosine. So now we know sine is very historic. It is connected to cos, which is given by which is actually cosine, and cosine of theta is x over square root of x squared plus y squared. So from these two equations you can you can figure out the famous identity for cos and sine, which is cos square theta plus sine square theta is equal to 1. And you will definitely use this identity in a lot of applications. And also you can see why this tool to figure out the values of sine and cosine is correct, because in this unit circle of unit radius, the hypotenuse is always 1, so x square plus y square is always 1, and essentially x and y are, so the denominator in both of these equation becomes 1 for this unit circle, and sine of theta and cosine of theta are just x and y in this case. So like this is a very basic introduction to sine and cosine. You will definitely read more and know more about this through the trigonometry lectures. But why is this relevant for, and how is this relevant for functions is what we'll see now. So once you have sine and cosine, next you want to figure out the domain and range of these functions. So one thing that you can see is this theta in this circle can only be between 0 and 360 degrees, but that is not preventing us, that is not preventing the domain from being between just 0 and 360 degrees, because let's say if I take a nail which is attached to the thread here, and I rotate it. The first time it will rotate 360 degrees, the next time it will rotate more than 360 degrees, and subsequently it will keep on accumulating angles. And similarly I can go in the negative direction too, and sine and cosine, which are given by x and y along this unit circle, are always defined. So sine and cosine, both of these functions, they have repeated values, so they are functions, they are periodic functions, and we'll learn more about periodic functions. So this tool lets us see that even for theta which is more than 360 degrees, which we typically use in circles, the function just repeats its values. So we have cos of theta, sine of theta, and the values of which keep on repeating. So sine and cosine are sort of functions which are periodic and can be given by this tool, and for which the domain, as we saw from this tool, is the whole real line. And next thing is the range. So range for sine and cosine is again from this tool we can figure out, since this is a unit radius, this is plus 1, this is minus 1, this is plus 1, this is minus 1. So pardon my drawing, it's slightly skewed, but essentially what I want to show is this is 1, both of these are positive 1, negative 1, because this by definition is the unit radius circle with and hence from this we know that sine theta is y upon the hypotenuse, which is 1 in this case, and y just goes from plus 1 and between minus 1 and plus 1. So range for sine, and similarly for cosine, is between minus 1 and plus 1. So for both of these functions the range is minus 1 to plus 1. So once again these are functions for which you would learn from a lot of places, and this was the aim of providing these two was primarily just to use them for the questions that we'll be doing in functions, but they are very commonly occurring functions, and you will it's very important to know more about them. You will definitely learn more, but I would again advise you to just try to remember this tool, which is sometimes useful. So now we have sine and cosine. So let's try to see some examples where we can try to find where we are given slightly more complicated functions, and we are trying to determine range and domain for those. Okay.